Hi, everyone. We are looking at our last topic in Chapter 4, which is part of Unit 3, dealing with congruent triangles. So we're looking at how we deal with isosceles and equilateral triangles, because there are different properties that come along with these specific kinds of triangles. So I want to spend a little bit of time just going over those kinds of properties. All right, so we're going to start with isosceles, and we've got some things to remember here. So like it says, remember, isosceles triangles have at least two congruent sides. And we're looking for, again, the dashes. Those dashes are what helps me find where those congruent sides are. So that's our classification that we had. Now, when we have isosceles triangles, there's other congruent things that we also get. Outside of the two congruent sides, we also get two congruent angles that are called base angles. Okay, the third angle, the one angle that is not congruent to the other two, is called a vertex, or your vertex angle. Now, those two congruent sides have specific names to them, and we call those legs. Just like you have two congruent legs, so does the triangle. And then the one non-congruent side, the one side that is different, is called the base of the triangle. Now, keep in mind, guys, base, this word, does not necessarily mean bottom. Okay, base in this case does not mean bottom. So meaning, depending on how that triangle is turned, the one side that is not congruent to the other two may not always be the bottom of the triangle. Just depends on the orientation or how that triangle is resting. Depends on where your base is and the congruent legs. Okay, so let's see what happens with this triangle we have here. We're going to label our different parts. All right, so the first thing we need to find is the definition of the isosceles. Says it's got two congruent legs. So let's get those two congruent legs up here. So we're going to let those be our legs. So we've got one leg on the left, one leg on the right, which means the other side, again, not necessarily the bottom, but the one side that is not a leg is called your base. So there's our base side. And I'm actually going to move that down. All right. So sorry, let me get the triangle back up here. All right, now let's look at your angles. Now, because the two congruent angles are called base angles, then let's take a guess of where they might be. Because of the name base, your base angles are the two angles that the base is connected to. Make this just a little darker. Yeah, so those are the two angles that are on the base. Those are your base angles. Now, if this triangle was turned around and that base was on the top, then your two base angles would also be on the top. And so now that we know where our two base angles are, I also know where my vertex angle is, because it's the one angle that is not congruent to the two bases. So in this case, that is the angle across from the base. That is your one vertex. Okay, your vertex are where the two legs are coming together. That's the included angle of your legs, called our vertex. So let's see what all of this means when we start using our different properties. All right, so example 1, find the value of x and y in the triangle at right. Okay, so let's focus on our picture. So the first thing we want to see if we can find is the congruent pieces, either the congruent legs or the congruent base angles, because I can use that to reference where everything else is located. In this specific triangle, I've got the congruent dashes here, so that tells me these are my legs. Okay, and again, where those two legs come together, that is my vertex. Which means my other two angles are my base angles. Okay, so since we've already got two expressions there for the legs, let's start with y. Now remember, legs are congruent. So those two pieces, if I have to have congruent legs, then one thing has to equal the other. So in this case, 4y minus 2 needs to equal the other leg, 2y plus 2. And we'll use this equation to solve. Let me make sure I'm not too large there with color. All right, so let's subtract our 2y from both sides. 4y, take away 2y, leaves us with 2y. I still have a minus 2, and it still equals the 2 on the other side. Now we can add that 2 back. So my 2y is equal to 4. Divide out the 2. And my y is equal to 2. So we found the first one. Now let's see if we can get the other. All right, so remember we said that the base angles have to be congruent. So if one base angle is 6x plus 8, so is the other. All right, now I have all three angles inside my triangle, my one vertex and my two congruent bases. I can use that to solve for x, because remember, all three angles in the triangle are supposed to add up to 180. So all three should add together and be 180. So I've got my one vertex, my two congruent base angles, and now I've got one long algebra problem. I can solve this down. All right, so I've got 6x and a 6x, so that gives me 12 x's. I'm going to zoom in a little more here. 80 and 8 and another 8 give us 96 equals 180. And this is where I can start my solving because I've combined all my terms. So 180 minus 96, because we need to subtract out what we've used, cancel out your plus 96. So 12x is equal to 180 minus 96 is an 84. All right, now we can divide both sides by the 12. And my x is equal to 7. And now we have our x and our y. So again, knowing the definitions and the properties of isosceles allowed me to solve at least for my x and y. Because again, I need to know that the legs are equal to each other. And if I know one base angle, I automatically know the other. So that's where I get that second 6x plus 8. Because again, base angles are congruent. All right, let's check out another problem with an isosceles triangle. Oh, sorry, it froze on me for just a second. Find the values of Z and SR in the triangle at right. All right, so this time we have a different picture. Now this time, notice they don't give me the congruent legs, but they do give me the congruent angles because of those curves that are there. Remember those curves, those arcs in the corners and the spaces are telling me where my angles are congruent. So if those two angles are congruent, those are my base angles. So that means the third angle has to be the vertex. And that tells me where my legs are at. So the rule says the legs have to be equal. So let's solve for the legs. So one leg will equal the other. So we have 2z minus 15. And my other leg is 9. And I can solve for this. Okay, we can add that 15 back. So 2z is equal to 24. Divide by your 2. And my z is a 12. So there's our first part. Now we need to find the length of SR. Because remember, no symbol, just so that we can remember this. Oops, sorry, it's a little too big. If there's no symbol on top of those letters, that means length. So as words, that means the length of SR. Okay, so no symbol on tops means length, or the length of segment SR in this case. That's what we're trying to figure out. Well, if S to R is 2z minus 15, now I know what z is. So 2 times 12 minus 15. 2 times 12 is 24. Minus 15, so SR should be 9. And when we plug that back in, we should in fact get the 9, because again, if the legs are supposed to be congruent, then S to R should also be a length of 9. So you want to make sure when we plug it back in, we do in fact get 9. So those are your isosceles triangles. So it's all about looking for the congruent parts in these triangles. And let's do one more example in case they only give you the vertex. I'm going to add one more down here at the bottom. So let's say, guys, that they only give you the vertex angle and they might want you to find the other angles. Okay, so remember, if this is my vertex at the top, and let's say it is 50 degrees. Well, if that is supposed to be my vertex, that makes those two my congruent legs, which would make the other two my base angles. So just from angles, I don't have enough to find the legs, but from one angle in an isosceles, I can use that to get to the other two angles. Because again, out of 180, 50 has been used up for 130. Well, remember that 130 is supposed to be the total of those other two. And since those other two are equal, I can divide that 30 by 2, and each of them would then need to be 65. Okay, so I just wanted to do another quick one real quick to see how you can get the other two angles if they only give you the vertex. All right, now let's look at our second triangle, which is the equilateral. Equilateral was a special kind of acute triangle, and it's also a special type of isosceles triangle. When we first looked at this with our classifications, we said equilateral triangle has all congruent sides. So all sides are going to be the same value, the same measure. Now we also talked about that if a triangle is equilateral, then it's also equiangular. Which means all angles are equal. And since we know that triangles total 180, 180 divided by 3, all of them are equal to 60 degrees. So let's take that and apply it into this triangle that we have here. So if this is supposed to be my equilateral triangle, then all 3 sides are the same. They don't have names. They're just all 3 congruent. We don't have legs in this one. And because it's equilateral, I also get 3 congruent angles. So there is not a separate vertex and base angles here for equilateral. And more specifically, they're all 60s. So if I know one, I already know the others. If I have all congruent angles, I get automatically congruent sides. If I get equilateral, I get equiangular. If I get equiangular, I automatically get equilateral. So sometimes it might not be so obvious of what my other 2 sides or my other 2 angles might be, especially if I don't know if I'm dealing with an equilateral or equiangular triangle. So let's see what happens with the ones that we've got so far. So example 3, find the measure of angle Y and find the measure of angle Z and then the length of YZ. All right, so right now, first thing I notice, I have 2 congruent sides. I only have 2 sides with the same measure right now. And those are my 2 sides with 8. So right now, those could be my legs. And if this is just technically as it looks right now, an isosceles triangle, that makes this 60 at the top possibly a vertex. Okay, so if that's my vertex, we can do the same thing we did before to figure out what's going on at the other 2 angles. Because right now, if this is in fact just an isosceles, these 2 angles are supposed to be the same. So let's solve for those missing 2 angles real quick, and then we'll see if in fact it is equilateral, equiangular or not. Okay, so 180 minus the 60 degrees from the vertex gives 120. And then my 2 base angles, so I'm going to divide that by 2 for them, which means each one of them is in fact 60 degrees. Now you've got 3 congruent angles, so that means this is equiangular. And if I have equiangular, I automatically get equilateral. Okay, so all angles are the same. Oops. So it's equiangular. And again, equiangular gives equilateral. So if I know now that this is equilateral, all sides have to be exactly the same. So that is another 8 inches. All right, so the measure of angle Y is 60 degrees. The measure of angle Z is 60 degrees. And the length of YZ, 8 inches. So just knowing equilateral from equiangular gives me all of my other information. So let's try one more now that actually has some algebra involved. So example 4, 2 more, sorry. Find the value of angle X and Y in the triangle at right. All right, so similar idea as before. Right now, as it looks, I only have 2 congruent legs. So if I know one is 3 inches, I automatically get 3 inches for the other. Where they come together is my vertex. So these other two angles have to be my base angles, which means if B is 2x, so is C 2x. And now I can solve this. Now notice before we do anything else, all three of these angles are exactly the same. Even though they're equations, they're still all the same. So when I solve this for my x and plug it back in, I should get the same values. So let's see what we get here. Let's solve this for x. So the rule says to solve for the angles in a triangle, add all three of them up to make 180. And if each one of them is 2x, so I have 6x is equal to 180. Divide by 6. And x is 30. So there's my missing x. And when I go back to these triangles and plug them in, if I go back and plug this in, I have 2 times 30 for each one of these. So 60, 60, and 60. So that means this is an equiangular triangle, which means all sides are the same. So that means 4y minus 5 is congruent to one of those sides that we thought were legs. So those two should be congruent and equal as well. So 4y minus 5 equal to 3. So add the 5 back. So 4y is equal to 8. Divide out your 4. And y is 2. And so there's our final answer. So again, we had to figure out the equiangular first, and then I could use that to set the sides of the triangle equal to each other. So let's try one more. Find the value of x in our specific triangle here. Okay, so one thing I noticed, all of these angles in this triangle have 1 dash each, which means 180 divided by 3. So all three of these are 60 degrees, which means this is equiangular. So these two are equal. Because if I get equiangular, I automatically get equilateral. So 2x plus 11 will equal the other side, 6x minus 9. And let's solve this. So I'm going to subtract my smaller variable first, so minus 2x to both sides. So 11 is equal to 4x minus 9. Add that 9 back to both sides. 20 is equal to 4x. Divide both sides by that 4. And my x is equal to 5. All right, so guys, I hope you enjoyed learning a little bit about isosceles and equilateral triangles. Please don't hesitate to reach out to me if you have any questions. And just like we looked at with our last couple of assignments and practices, it's very important to pay attention to the markings in those triangles. Because again, that tells you where the congruent parts are going to be, or the legs, or the congruent angles, or the base angles. It also helps you find where the vertex is, which is extremely important when it comes to isosceles. So please, guys, if you have any questions at all, don't hesitate to reach out to me. Bye.